Hi everyone, Alistair here. This is the test review for test number 2, which will be Monday. So, what I recommend doing, go through all the problems yourself. Whatever you can't do, star it, come to the video, check how to do it, make sure you know how to get the right answer, and whatever ones you were able to do by yourself, again, check the video, scroll, see if you got the right answer. You got the right answer, you're good. Move on to the next problem, right? You do all the questions, get 5 extra points on your test, and an opportunity to get 8 extra credit points on your test, which I recommend doing because knowing how to explain something will always lead to you knowing how to do something. That's why I've been emphasizing explanations lately. All right, as you can see, there's an explanation how to do a long division here. So if you do this for all the problems, you get 8 extra points. And maybe I'll be generous. Maybe if your explanations are really good, I'll give you 10 extra points, right, on your exam. All right, so let's get started on the first problem, right? So the first problem here deals with the fundamental theorem of algebra and zeros. So it's giving you two functions. A function p of x, which is 3x cubed plus x squared minus 5x. And it's giving another function, y equals m of x below. All right, so now it's asking which statement is true, right? It's saying p of x has 3 real roots, m of x has 2 real roots, blah, 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 and so on and so forth, right, for the options. So one thing I always recommend doing, let's look at this function. P of x equals 3x cubed plus x squared minus 5x, right? So I always recommend going to your graphing calculator. You go to y equals, you put the function in, right? 3x cubed plus x squared minus 5x. You click graph. So it hits the x-intercept 3 times 1, 2, 3. So you know it has, in fact, 3 real zeros because it hits the x-intercept 3 times. All right, so let's take a look, right? So what is this supposed to be? 3 real zeros. All right, so I have some function 3x cubed. Because the highest power is cubed, it's going to have 3 zeros. It's going to have 3 zeros. Ooh, let me use a different color here. 3 zeros, right? And it hit the x-intercept 3 times, so it has 3 real zeros, right? 3 real zeros. And since it has 3 real zeros, it has 0 complex zeros, right? It has 0 imaginary zeros. All right, and then let's take a look at the graph below, y equals mx. So whenever you see a graph like this is usually, right, a W-looking graph like this. This is usually some quartic function. So this is to some function x to the 4th, right? Something to the 4th power, right? That's going to be the highest power, right? And let's see how many times it hits the x-axis, right? So I can see m of x hits once, twice right here. So it has supposed to have 4 zeros, but I see it only has two real zeros because it hits the x-intercept twice. So 2 real zeros. So it must have 2 complex zeros, right? So it must have 2 complex zeros. So let's take a look at our options, right? It says p of x has 3 real roots. Got it right here. And m of x has 2 real roots. And we got that right here. So our option is number 1. So we got lucky with that. All right. So that's how you do these problems when you look at a graph, right? Now, if I was asking the reverse, asking how many complex zeros does it have, you'd say 0 complex zeros and 2 complex zeros, right, for each respective function. All right, let's move on to the next function, right? So if you see a function like this, right, you see a function like this, it says, oh, which expression is equivalent to, right? This is usually a rational expression / long division problem. So let's go. Let's try it, right? Let's try the long division here. Let's set it up. This is x plus 6. And then I'm setting up the long division. 2x to the 4th plus 8x cubed minus 25x squared minus 6x plus 14. Oh my God, this one is huge, right? Why did I give this one to you guys? Anyway, let's take a look. Let's try the problem. All right. So I have remember, leading term divided by leading term, right? So I'm just gonna do the work here, right? I don't think I'll even have enough space, right? So I'm gonna work down here for a second, right? 2x to the fourth over x equals 2x cubed, right? So I'm going to write my quotient right here, 2x cubed, right? And then I'm going to multiply this by the divisor, so 2x cubed times x plus 6, right? I'm going to get 2x to the fourth plus 12x cubed, right? 2 times 6 is 12, and I bring over the x cubed. So now I'm going to subtract this whole thing right here. Subtract this whole thing, 2x to the fourth plus 12x cubed. I'm going to subtract this whole thing, right? Again, remember, when I'm subtracting, right, 2x to the fourth minus 2x to the fourth, so this cancels out. I'm on the right track, right? Now you have to be careful here. See, I see this common mistake a lot. Remember, there's a minus sign here. Don't forget to distribute it. So this becomes a minus 12x squared. So 8x cubed minus 12x cubed is going to give me 4x cubed, right? So that's what I'm going to get. Now I'm going to bring this down. This minus 25x squared, right? Again, rinse, repeat. Now I'm going to repeat, right? Leading term divided by leading term. So I'm going to do it right here. All right. So I'm going to have 4x cubed divided by x, which is going to be giving me 4x squared. I'm going to multiply that by the divisor. If I'm talking too fast, slow down the video, right? So I'm going to multiply 4x squared times x plus 6. And I'm going to get 4x cubed, right? And then 4 times 6 is 24. And I'm going to get plus 24x squared, right? And now I'm going to subtract all that. So let's do it. Let's subtract all that. Minus 4x cubed. All right, I know I'm on the right track because I can cancel them out. Plus 24x squared, right? All right. All right, let's write our quotient right here. 4x squared, right? I got a positive. So I'm sorry, it's supposed to be a negative, right? It's supposed to be a negative 4x squared, right? Negative 4x squared right here. So I get negative here, right? So I'm just fixing out my work here, right? I'm just going to reverse the sign of everything. All right, so I'm going to get negative here and a negative here. All right, so just fix that up. Minus 4x squared. All right. So let's do that. Negative is positive, so these two cancel out. Negative 4x cubed plus 4x cubed, 0, right? So now I have a minus 25x squared minus. So minus is plus. Minus is plus. So minus 25x squared plus 24x squared minus 25 plus 24. All I have is minus x squared left over here, right? All right, let's put it on a different color, right? And now I'm going to bring down my minus 6x, so minus 6x. All right, we're going to repeat the process again. Leading term divided by leading term. So minus x squared divided by x is going to give me minus x. I'm going to multiply that. I'm going to multiply all that by my divisor, x plus 6, right? X plus 6. So I'm going to get minus x squared minus 6x. So minus x squared minus 6x. All right, now I'm going to subtract this whole thing. So let's subtract. Subtract minus x squared minus 6x. All right. What do I get here? Put in a different color. Minus x squared minus is positive. Minus is positive. So I'm just changing my signs, right? So minus x squared plus x squared. This cancels out good. Minus 6 plus 6. This also cancels out. So that's good, right? So that's good, right? So I forgot to put my quotient here. Now I bring down my 14. So 14, right? 14 is not properly divided by x, right? So that's just my remainder here, right? So I have 2x cubed minus 4x squared minus x plus, right, there's a positive 14 plus 14 over x plus 6. And that is my final answer. 2x cubed minus 4x squared minus x plus 14 over x plus 6. So if you got that, good job, right? So good job right there. Let's move on to the next problem. This is a solving radical problem, right? So we've been doing a lot of quadratics lately, and this is what it's going to lend itself into, all right? All right. Okay. All right. So let's choose a nice color right here. All right. So remember, the way to solve most of these radicals, right? This is a square root. How do you cancel out a square root? We have to square it, right? So let's square both sides, right? So let's square both sides. So you have to square both sides here, right? So when you square root a radical, it goes away. So I'm just going to have x squared minus 4x minus 5 equals 2x minus 10 squared. So that's 2x minus 10 times 2x minus 10. All right. All right, so we obviously have to expand this, right? 2x times 2x is 4x squared. 2x times negative 10 is negative 20x. Negative 10 times 2x is, again, negative 20x. Negative times negative 10 is positive 100, right? I'm going to bring this down. All right. All right, this is a quadratic, right? It's a quadratic, so what I'm going to do, I'm going to move everything to one side. I'm going to combine like terms and move everything to one side. So let me combine the like term. So let me move everything to one side. So I'm going to have 0 equals, I'm going to subtract this whole thing from this equation. 4x squared minus 20x minus 20x plus 100 plus 100 minus x squared. There's a positive x squared, so to get rid of that, plus 4x, right, minus 4x, so I have to add a 4x to get rid of it, and plus 5, right, and plus 5. All right. All right. Okay, let's go. Now let's combine some like terms here. All right, so 4x squared minus x squared, I'm going to have 3x squared minus 20x minus 20x plus 4x, so minus 20 minus 20 is minus 40. Minus 40 plus 4 is minus 36x. And then I have 100 plus 5, which is plus 105, right? Plus 105, right? Well, you know, we could, it's your choice if you want to use the quadratic or factoring, right? So this is a big one. You could factor it, right? We could take out 3 from everything. So if you're able to factor it, that's good. Let's just use the quadratic because that's what we're used to recently, right? So my A here is, A is 3. B is negative 36. C is 105. Oh my God, this is too much. Maybe we should factor it, right? All right. Okay. Yeah, maybe we should factor it. All right. All right. All right. Let's just use the quadratic. All right. So I'm gonna have first thing. Remember, in the quadratics now we do this, right? We do b squared minus 4ac. We put that in first, right? So take out your calculators, right? You're gonna have b squared minus 4ac, right? So calculate that first, right? And remember, the whole quadratic is x equals minus b, so minus 36 plus minus square root of minus 36 squared, right? Minus 4 times a is 3 and c is 105, right? Over 2a and a is 3, right? So let's see, let's put that all in the calculator. Let's see what we get for our x values. So go back to my calculator, right? So I'm gonna go to boom, 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 a second quit, right? I'm going to make a, I'm gonna see the discriminant first, which is going to be negative 36 squared minus 4 times a was 3 and c was 105, right? So what am I gonna get there, right? I'm just gonna get, wow, nice, right? Just 36, right? And I'm gonna put this whole thing in the quadratic, right? So I'm gonna do alpha y equals n slash d, right? So I have my discriminant. Remember, the discriminant is the square root thing, right? So I'm gonna have minus b, so minus 36 is just 36. Let's do the minus part first. Minus second square root. Remember, this whole thing is under the square root over 2 times 3, right? 2 times 3. Press enter. All right, so I got 5 for my first one. Right, I'm going to do this one again, and I'm going to get, I'm going to do the addition part. All right, so I got 5 and 7. 5 and 7 were my two solutions. All right, let's go back into our paper. So I got x equals 5 and 7. I got x equals 5 and 7. X equals 5 and 7. Remember, radicals, you have to check, right? You have to check because we can have extraneous solutions, right? So you have to check. So you have to put this back in, right? So you have to check. So let's check 5 first. All right. Square root of 5, wherever I see x, I'm going to replace it with 5, right? To see if this works out. 5 squared minus 4 times 5. Minus 5, so you can put this in the calculator. Does it equal, right? 2 times 5 minus 10, right? So you're going to get square root of 25 minus 20 minus 5. Is this going to equal 10 minus 10? So yeah, that is, right? This whole thing is 0. This whole thing's 0. So this one checks out. So 5 checks out, right? So let's also try 7, right? Let's also try 7. Let's try square root of 7 squared minus 4 times 7 minus 5, right? So that's going to be 49 minus 28 minus 5. Is that going to equal 2 times 7 minus 10? So it's asking, is this going to work? So if I put that in, right? So 49 minus 28 is 21. 21 minus 5 is 16. Does 16 equal 2 times 7 is 14? 14 minus 10 is 4, right? Does the square root of 16 equal 4, right? So yeah, it does. The square root of 16 is 4. So both of my solutions work. None of them are extraneous. So my final answer is x equals 5 and 7. All right. All right, let's go. I hope this video is recording. If not, I'm totally screwed. I'm gonna have to do this all over again. All right, let's choose a different color. Right, let's make it a little thicker. All right, so now same thing, solve algebraically. Remember, I want the square root on one side and everything else on the other side, right? So let's add, right? So let's add x to both sides, right? Let's add x to both sides. So I get square root of x plus 5. X plus 5 equals 3 plus x, right? 3 plus x. All right. Now, square root is on one side. Nothing's bothering it. Everything else on the other side. I'm going to square root both sides. I'm going to square root both sides. All right. So I'm going to get square root plus times the square cancels itself out. So I'm going to have x plus 5 equals 3 plus x squared. So I'm going to have 3 plus x times 3 plus x, right? So I'm going to have x plus 5 equals 3 times 3 is 9. 3 times 3 is 9. 3 times x is plus 3x. X times 3 is plus 3x. X times x is plus x squared, right? x squared. All right, so let's combine all the like terms here and subtract this. This is a quadratic, right? Let's subtract this. Oops, let's subtract this from both sides. Let's subtract x, that's fine, from both sides. All right, so I'm going to get 0 here, 9, 3x plus, so I'm just, let me just rewrite it, 3x plus x squared minus x minus 5, right? So I'm going to combining like terms, 0 equals, I'm going to put the x squared up front, x squared, so 3x plus 3x, 6x minus x is 5x plus 5x, right? Minus 5 and 9, right? 9 minus 5 is 4, right? So plus 4, right? Okay, we could use the quadratic to solve, so if that's more comfortable for you, use it. But this one is really, really easy to factor, right? So I'm going to do that for this one. So let's think the factors of 4 that add up to 5, right? This is easy, right? 4 times 1. 4 plus 1 is 5, right? So I have x plus 1, x plus 4, right? So those are my factors. So my zeros are x equals -1 and x equals -4. Remember, I have to plug this back in, right? See if it works. If it doesn't work, my solutions are extraneous, right? So I'm going to have to plug this back in. I'm going to plug in wherever I see x. I'm going to plug in -1 and then -4 to see if my solutions work. So let's do it. Let's check x square root. So -1 plus 5 minus -1. So minus, and my x is -1. So that's on -1. Does this equal 3, right? So -1 plus 4, that's square root of 4. Minus is positive. Does that equal 3? Yes, square root of 4 is 2. 2 plus 1 equals 3. So this one works out. So this one works out. All right, now let's try the next one. Let's check our next solution. All right, gonna plug this in. -4 plus 5 minus 4. All right, does that equal 3? All right, minus 4 plus 5 is square root of 1, which is just 1. Minus is what? Minus is plus 4. Does that equal 3? Well, square root of 1 is 1. 1 plus 4, does that equal 3? No, it does not. So this solution does not work out. It is extraneous. So my only solution here is x equals -1. And if you got that, good job, right? Good job. All right, let's try this. This is a quadratic solution, just kind of a same old thing here, right? So remember, to solve a quadratic, I gotta set it equal to 0. So I'm gonna add 7 to both sides, and I'm going to get 3x squared plus 2x plus 7 equals 0. All right, so equals 0. All right, so give me a second here. All right, so again, let's use the quadratic here. A equals 3, b equals 2, c equals 7, right? So remember, first thing we do is the discriminant, right? Which is b squared minus 4ac, which is going to be 2 squared minus 4 times a is 3, and c is 7. C is 7. So I'm going to get 4 minus 4 times 3 is 12. 12 times 7 is going to be 84. So I'm going to get 4 minus 84. So I'm going to get minus 80. Whoa, this is a negative square root. A negative square root implies what kind of solution here? This is going to be a complex solution, right? So I'm going to break up this negative 80 here. Break up this negative 80 here, right? All right, break up this negative 80, right, into a complex solution. I can express this as, what was that? Let's undo that, all right? this is going to be negative 1 times 80, right? The square root of negative 1 is I. And I'm going to break up the 80 into, remember, this is where your times table comes in, right? And you could do the prime factorization. I'm going to skip it for now. This is going to be 16 times 5, which is going to give you 80. So square root of 16 is 4. So I'm going to get 4 I square root of 5. And I can't reduce the 5 anymore. So that's my b squared minus 4ac. So I'm going to plug this into the quadratic equation. I'm going to have x equals minus, right? Minus 2, so minus b, plus minus 4i square root of 5 over 2a, right? So 2a, a is 3. So I'm going to have 2 times 3. All right, so I'm going to get x equals minus 2 plus minus 4i square root of 5 over 6, right? This is reducible, right? 2 goes into negative 2, 4, and 6, so I can reduce this. So x is going to equal negative 1 plus minus 2i square root of 5 over 3. All right, so that's my final answer. Those are my two solutions. X equals negative 1. So just for clarity's sake, negative 1 minus 2i to the square root of 5 over 3. And they always come in pairs, so I'm going to have negative 1 plus 2i square root of 5 over 3. Those are my two solutions, right? Those are my two solutions to this quadratic, right? So this was a little different from the other ones because this gave us a complex solution. So if you got that, good job. If not, take this down. All right, remember radicals? We were doing this like a couple of weeks ago. So let's work on some radical problems, right? So it's saying for x equals 0, which expression is equivalent to, right? There's a couple of things you could do here, right? Let's do it algebraically first, right? Let's do it algebraically first. So let's convert all of these singular parts into fractions. So remember, everything, right? Just the standard here is, right, x to the m over n always looks like this, right? This looks like x to the m to the nth root, right? So they all look like that. So let's convert them all to that. Let's do it algebraically. All right. So let's convert this one. So I'm going to have, remember, 3 x squared. This is going to be x to the, remember, the outside is, the inside exponent is the numerator, and the outside is the root. That's the denominator. So that's that one, right? So now I'm going to do x to the 5th, right? So x to the square root of 5. Remember, if there's no square root here, there's an invisible 2, right? So this is going to be x to the 5 over 2. And this one, I have square root of x, the 6th root of x, right? So I don't see a power here, right? So this is technically x to the 1 power. So this is going to be x to the 1 over 6. All right, so let's multiply all of that, right? Okay, so I'm going to have x to the 2 over 3. I converted everything times x to the 5 over 2 over x to the 1 over 6. All right, so when you multiply the same base, right, when you multiply the same base, remember you're adding the exponent. So we're adding 2 plus 3 plus 5 over 2, right? We can't do this, right? We need a common denominator, right? And the common denominator for that 3 and 2 is 6. So, all right, so I'm going to have, to get to 6, I'm going to have to multiply this whole thing by 2 over 2. And to get to 3, I'm going to have to multiply this thing over by 3 over 3. So I'm going to have 4 over 6 plus 5. 3 times 5 is 15. And 3 times 2 is 6, right? So I'm going to get 19 over 6, right? So for the top portion, I'm going to rewrite this right here. I'm going to rewrite it in blue. I'm going to have x to the 19 over 6 over x to the 1 over 6. Remember, when I'm dividing exponents, it's subtraction, right? So I have to keep going. I have to do x to the 19 over 6, and I'm going to subtract my exponents 1 over 6. So that's going to be what? That's going to be 18 over 6. What's 18 over 6? Is that perfectly divisible? Yes, so that is just 3. So my final answer is x to the third after all that simplification, right? So what we did is we converted all our radicals into exponent form, and then we rewrote the problem right here. So we converted them all right here. We rewrote the problem right here. We realized when we're multiplying the same base, right, we have to add exponents. So we added our exponents. They were of a different denominator, 3 and 2, right? The smallest thing, multiple of 3 and 2 is 6, right? So that we converted everything into 6, right, as our denominator, and we multiplied. How do you get to 6? Right, from 3 you multiply by 2. How do you get to 6 from 3? You multiply by 3. We added everything, and then we realized we have the same base, right? So we subtract the exponents. 19 over 6 minus 1 over 6, right? And we see that's 18 over 6, and that is 3. So we finally get x to the third, right, in the simplest form. All right, next problem, same thing, right? So I have m of x and p of x. M of x equals 12x 8a, and p of x equals 3x 2a. So this expression is equivalent to what? All right, so let's go, right? Let's do, it's going to be m of x over p of x. So m of x over p of x, which is just going to be 12x 8a over, all right, 3x 2a, all right, 3x 2a. All right, so let's reduce, right? What's 12 over 3? That's 4, right? And x, this is the same base, right? So x, if it's the same base and it's division, right, we subtract the exponent. So I got 8a minus 2a, which is just going to be 6a. So this is 4x 6a, and that's it. That's my final answer, right? That wasn't that bad. Oh boy, another quadratic, right? So how do you do a quadratic linear system, right? So you have to, you're solving for a set of coordinates, right? So this looks something like this, right? This looks something like this, right? So, right, and it's like we're solving for an intersection, right? Usually 2 points, right? Sometimes just 1 point, or we're solving, right, for an imaginary solution. So they wouldn't really intersect, right? They look something like this. They wouldn't really intersect, but they're intersecting like on the imaginary plane. All right, so that's what it kind of looks like, right? So first thing we do here is, remember, these problems, they don't always ask you to solve for everything. Sometimes they ask you what the solutions are going to be. Sometimes they ask you what your just x is. They're not asking for x and y, right? But over here they are asking for x and y. So let's do it. Let's first thing you want to do is isolate y, right? You want to get y by itself. Well, lucky us, the y is by itself. After you isolate y, right, you substitute to solve for x, right? So you rewrite the first equation, x squared plus, instead of writing y, you're going to substitute this, right? When you just have one variable, you can solve. So x minus 28 squared equals 400. All right. So this is going to be x squared plus x minus 28 times x minus 28. I'm just going to move the 400 to this side because this is a quadratic, and I'm going to need to do that anyway. 0. All right. So I get x squared. X times x is x squared. X times negative 28 is negative 28x. negative 28 times x is negative 28x. Negative 28 times negative 28. Oh man. All right, let me check what this is. Negative 28 times negative 28. So do this on your calculator. So this is just going to give me positive 748, 784 minus 400, 0. So I'm just going to combine like terms here. X squared, I get 2x squared. Minus 28 is going to be minus 56x. 784 minus 400, I'm going to get plus 384. All right. All right. So let's have this equal to 0, right? Okay. All right. Well, so let's deploy the quadratic, right? Why not, right? You could factor this, but let's deploy the quadratic, right? All right. So I have e equals 2, b equals negative 56, c equals 384. All right. So first thing I'm going to do, I'm going to look at my discriminant, put that under the square root. All right, what is this going to be, right? All right, so we have minus 56 squared minus 4 times a is 2, c is 384. All right, let's take out our calculators, and let's put this in. All right, so I'm going to have negative 56 squared minus 4 times a was 2, and c was 384. Okay, so, oh wow, nice, right? 64. So that's my discriminant. So 64, nice whole number right there. All right, so I'm gonna get this, gonna be just square root of 64, which is just 8, right? So that's what I'm gonna get from my discriminant. So let's plug that into the quadratic. X equals minus b, so minus 56 plus minus 8, right? I'm not going to do this discriminant again. I already found it was 8 over 2 times a, which is 2. So I'm going to have 56 plus minus 8 over 4. All right. So I'm going to get my first solution. Right? I'm going to get first solution is going to be 56 plus 8, which is 64. 64 divided by 4 is 16. 56 minus 8 is 48. 48 divided by 4 is 12. So these are going to be my two x solutions, right? I'm not done. I have to find where they intersect. So I'm going to plug this back in to find my y, right? So I found my x's. So x equals 12 and 16. All right, now let's find my y's, right? I'm going to plug it in back there. So wherever I see, so y equals 12 minus 28. So, all right, so I'm going to, 12 minus 28 is negative 16. So that's going to be negative 16. So my first set of coordinates is going to be 12 and negative 16. So now I'm going to check the other ones. Y equals 16 minus 28, which is going to be negative 12. So my second set of coordinates where they intersect is going to be 16, negative 12. Wow, that worked out neatly, right? So this is my solution, right? I'm going to box it or something. That's my solution. That's all the work, and that's my solution. All right, so that's how you solve a quadratic system. These 2 points, right, these 2 coordinates, put in parentheses, is where they intersect. All right. So now let's solve this, right? All right, so it's asking us to evaluate j of -1, and it's asking us, right, what does that mean? What does that tell us about it? Is it a factor? If it has a remainder, it's not a factor. So it's just asking us to evaluate. So we have to do the work here. So 2, -1 to the 4th power. So wherever I see x, I'm going to replace it, right? Minus -1 to the 3rd, minus 35, -1 squared, plus 16, -1, plus 48. All right, so this is going to be 2 times 1. -1 to the 4th is 1. This is going to be -1 to the 3rd power is -1, so it's going to be plus 1. -1 squared is 1, so it's going to be minus 35. 16 times -1 is going to be minus 16 plus 48. All right, so 2 plus 1 plus 48 is 51. Minus 35 minus 16 is 0. So this whole thing is going to give me 0. So this I'm going to write, right? What does this, they're asking us to explain, right? They're going to say, right? So x plus 1 is a factor because there is no remainder when evaluating the function. All right, yeah, we're done, right? I wish, right? So now we have to algebraically find the remaining 0. So what do we do here? More long division, right? So we're gonna divide this whole thing j of x by this factor x plus 1. Let's set this up, x plus 1 over 2x to the 4th minus x cubed minus 35x squared plus 16x plus 48. All right, I should have given you guys less problems on the review sheet because I'm having to do so much explanations. All right, leading term divided by leading term, 2x to the 4th over x equals 2x cubed. Multiply my divisor by that, 2x cubed times x plus 1 equals 2x to the 4th plus 2x cubed. All right, so I'm going to subtract that whole thing. 2x to the 4th plus 2x cubed. I'm going to subtract this whole thing. This cancels out. Write my quotient, 2x cubed. Minus positive is just negative, so minus x cubed minus 2x cubed is going to get minus 3x cubed. Bring down my minus 35x. All right. Now I'm going to leading term divided by leading term. Negative 3x cubed over x equals negative 3x. Multiply that by the divisor. I'm going to get negative 3x cubed minus 3x. All right, so minus this whole thing, minus negative 3x cubed minus 3x. All right, so this is going to be negative is positive, so this cancels out, right? Negative is positive, so minus 35x plus 3x is going to be minus 32x. All right, where my quotient here? All right. Sorry, these are all squared, right? So these are all squared. I know something looked wrong. All right, so we get minus 32x squared. All right, so now we just repeat the process until we get our answer. Leading term, bring down the plus 16x. All right, so I'm going to have minus 32x squared over x equals minus 32x. Multiply that by my... So this is going to be minus 32 this is going to give me minus 32x squared minus 32x. All right, so now subtract that whole thing. Minus 32x squared minus 32x. All right. Okay, now what do we do here? Minus minus is positive, minus minus is positive, so this cancel out. I get 16x plus 32x is 48x. We're going to now 48x. I'm going to bring down the positive 48. So leading term divided by leading term. I'm going to have 48x divided by x equals 48. So I'm going to multiply that by the divisor. That's 48. It's 48x plus 48. Subtract this whole thing, so minus 48x plus 48, right? So as you can see, these two quantities are equal, so they just cancel out, right? Minus 32x plus 48. All right. Okay, so I'm done, right? Right, nope. Now I have to find the remaining zeros of j of x, so I'm going to have to factor this, right? So I'm going to have 2x, let me change to a different color. 2x cubed minus 3x squared minus 32x plus 48. All right. Okay. All right, let's try some factoring by grouping, right? So what do they both share? What do these both share? Right, these share an x squared, right? So I'm going to pull out an x squared from both. So x squared, all I have left is 2x minus 3. What do these both share? What number do the largest number that goes in both, right? Is 16, right? So minus 16. I have 2x here. How many times does minus 16 go into positive 48? It goes into minus 3 times. All right, that's great. So now I have x squared. I'm gonna bring my outside factors together, bring down my inside factors. All right, now this, remember, it's a difference of two squares. So I can break this up into x plus 4, x minus 4 times 2x minus 3. Now remember, it's asking to find the remaining zeros, right? They give you one of the zeros, which is negative 1. So the 0 for this is negative 4. 0 for this is 4. And the 0 for this is, let's work it out, 2x minus 3 equals 0. 2x equals 3. X equals 1.5, right? All right, so my final answer, right, is the remaining zeros are going to be x equals negative 4, 1.5, 4. So you can do that, circle that. If you want to add a negative 1 as well, that's fine. No one will deduct you for that. All right, so that's how you do this whole problem. This thing is literally the same exact problem as last time. So again, over here, how am I going to check if this is a factor, right? Just to start you off, right? What is the 0 of this? X plus 3 equals 0, so x equals negative 3, right? Negative 3. So how do they want you to do this? They're asking you to find f of negative 3. So wherever you see x, you're going to put a negative 3. Cubed plus 3x, negative 3 squared minus 2, negative 3 minus 6, right? So that's what they're asking. So same thing, you're going to have to do the long division. And I'm getting some water. All right, so you evaluate that. just like last time. So minus 27. Excuse me, minus 27 plus 27 plus 6 minus 6, which is going to be 0, right? So that's a factor. And then you set up the long division here. So x plus 3 x cubed plus 3x squared. Just do it like last time. You'd find the quotient, you'd factor the quotient, right? And then you would find what the zeros are. So because it's just like the last one, I'm going to go through it. It's the same exact process. All right. Now this is an interesting problem, right? All right, remember, this giving you a graph, right? This is giving you a graph, and it's asking what could the equation be in factored form, right? So remember, in factored form is always x minus your factor m, right? All right, so let's look at this, right? What's the 0 here? Negative a, right? So there's going to be x minus negative a and x minus b, right? X minus b, right? So that's what you think, right? It's like, oh, I have x plus a, x minus b, right? So I'm good, right? Wrong, right? So you have to recognize that the parent function, right? The base function of this is a cubic function, right? So it's a cubic function. It looks something like this. It looks a little off because it's hitting, right, the x-axis twice, and it's just two factors. Where's the third factor, right? So you have to recognize that. You have to recognize that the base function of this is x cubed. So there are two. So one of the zeros is repeated twice, and there are a total of 3 zeros. So let's see which one has a total of 3 zeros. This is not it. These are just 2 zeros here, so I'm going to cancel this out. This also 2 zeros, cancel this out. So this and this have 3 zeros, right? So which one is x plus a? It's this one, right? Not this one. So this is my answer, right? X plus a squared minus x plus b, right? So they say equation could be, not that it is, it could be, right? Theoretically, this is what the equation could be, right? And that's the closest match we have to this equation. All right. So this one is asking, sketch g of x equals minus 3x cubed minus 7x squared plus 36 on the axis below, including appropriate end behavior and zeros, right? So they're not asking for the y-intercept, although I'll show you what to do for the y-intercept, right? They're asking, again, just for the zeros. One thing I always recommend you guys always do is you see this, right? Put this in the graphing calculator. See what it looks like, right? See what it looks like. If that works, you are good. Let's go to y equals, right? Let's clear this. This is going to be minus x to the third power, right? It's going to be minus, is it minus x? Just checking again. Yep. Minus 7x squared plus 36. All right. So let's graph this, right? Oh, graph, perfect, right? It's x cubed. It has 3 zeros, right? I'm going to check my table to find all the zeros, right? Great, this is perfect, right? I have a 0 at negative 6. I have a 0 at negative 3 and a 0 at 2, right? So that's what I'm going to do, right? So I have a 0, right? Where are my zeros? Sorry. Give me a second. 0 is at negative 6. Where's my other 0? It's at negative 3, and my other 0 was at 2, right? And what's the y-intercept? The y-intercept is just going to be the whole number, which is 36, right? So like maybe somewhere up here, I'm going to write 0, 36, right? Just be a comma. All right. So what does it look like, right? Again, I'm going to check. I'm going to check what it looks like here. Boom. Go back to my graph, right? Maybe I'm going to zoom out a little bit, right? Right, okay, so that's what it looks like. All right. All right, so it looks something like, all right, it looks something like this, right? Oh, I got my x-intercept, I got my y-intercept, right? I'm good, right? Wrong, right? It's also asking for end behavior, right? So I could say, right? So what is my end behavior as x goes to negative infinity, which is this direction? Where is f of x going? F of x is going to infinity, right? It's going up, so it's going to infinity. As x goes to positive infinity, which is this direction, f of x is going down, so f of x is going to negative infinity, right? Now it's also asking for all the zeros. So where are the zeros, right? I could just write zeros, zeros, right? Zeros, or a lot of you write zeros, which is also okay, right? Are -6, -3, and 2, and that's the full answer, right? With the graph, all this, that you're good, right? So put that in, and that's how you graph it. We could factor this, right? I know this isn't easily factorable, but maybe I'll show you guys in class what to do on how to factor this. All right. So now I have, all right. So this are powers of I. You can see this. You can see some complex operations on the exam. So let's take a look. All right. So 8xi. So it's asking in simplest form, right? So remember, I to the 1 power is just I squared is -1, I cubed is -I to the 4th is 1, right? And we think in terms of remainder for the I, right? So what is going to be, and we divide by 4. So for this one, I to the 10th, right? So 10 divided by 4 is going to be 2 with a remainder of 2, right? So my I to what power is the remainder? So I'm going to have 8xi2, all right? Okay, let's work on this one. So minus I to the 19th, 19 divided by 4, I'm going to get is 4 with a remainder of 3. So remember, all I care is about the remainder after I divide by 4. So minus 4y I to the 3rd. All right, that's it. Over here, I have 2. Sorry, it's 3. Give me a second. So I'm going to have I to the 3rd. I to the 3rd. Well, that's just 3 divided by 4 is just 0, remainder 3. So all I care about is the remainder, right? So this is just going to stay I to the 3rd, right? Plus 2y I to the 3rd. And that one, I don't have to do anything, 6xi. All right. So now that I'm done this, I'm going to use this part. I'm going to use this part to solve, right? Use this part to solve. All right, use this. All right, what is I squared? I squared is -1, so I'm going to have 8x times -1 minus 4y. What's I to the 3rd? I to the 3rd is -I. Plus 2y, again, I to the 3rd is -I, minus 6xi. All right, so I'm going to have minus 8x, all right? Minus is positive 4y, minus negative is minus 2y, and then minus 6x, all right? So I can combine some like terms here. This doesn't have an I, this has an I, so I can't combine those, all right? I can't combine those, but these two I can combine because it's just yi and yi. So I'm going to have 2yi minus 6xi minus 8x. And that's my final answer, right? That's my final answer. All right. All right. This is a rational expression. Let's do this one. All right. Okay, first thing I do is I check what x can't be. X can't be what? 0, -2. So if I get these as solutions, I reject them. All right, now then what I do, I look for the LCD. LCD. This, what are the differences? X plus 2, denominators x plus 2 and x, right? So I'm just going to have x plus 2 times x, right? That's going to be my LCD. So let's do this. And now I multiply all the terms by my LCD. All right, so we'll have x plus 2 over 3x plus x plus 2 over x plus 2 x plus 2 equals x plus 2 times -2 x plus 2. All right, sorry about the spacing here. All right, so now let's cancel out some stuff. Cancel out the x's here, cancel out the x plus 2 here, cancel out the x plus 2 here. All right, so I get 3 x plus 2 plus x times x from here equals -2x. All right, because all I have left is an x and a -2. So I get 3x plus 6 plus x squared minus 2x. This is a quadratic. I'm going to put everything to one side. Just going to add the 2x. I'm going to put the x squared to the front. X squared plus 5x, right? 2x plus 2x. I'm adding 2x to both sides. Plus 6 equals 0. All right, we could use a quadratic here, and if you want, that's okay. This is factorable, very easily factorable. This is where a times table comes in. Factors of 6 that add up to 5, so it's x plus 2, x plus 3. These are our factors, so our zeros are x equals -2, -3, right? So I'm done, right? X equals this. I'm going to circle my solution right here, right? Well, wrong, right? Because if I look over here, it says x cannot be -2. X cannot be -2, right? So my real solution is x equals -3. That's my solution. All right. All right, let's try the next one. All right. So first thing I do is I check what x cannot be, right? X cannot be, right? Sometimes it's hard, right? Sometimes you have to factor the bottoms. I'm going to factor the denominators. So they both have m in common. And I'm going to take an m out, m minus 1. Plus 1 over m equals 5 m minus 1. All right. So now what can x not be? X can't be, it's just over m. Remember, there's also an m here, so x can't be 0, and x cannot be +1. So if I see these solutions, I'm going to reject it. What's the LCD? Don't get tripped up here. This thing already has an m. M squared minus m, when I factor it, is m times m minus 1. So this thing already has an m. And this thing is missing m minus 1. So I don't have to multiply this by m again because it already has m as a factor. This one is missing what? This one is missing m minus 1. So my LCD is m times m minus 1. Okay. I'm going to do it a little differently, right? Sometimes you can just skip the work, right? And you could just think about it, right? Like, I'm going to be able to when I multiply this by the LCD, I'm going to be able to cancel everything. So I just have 1 plus 1 times, what factor is this one missing, right? It's m minus 1, right? M minus 1, right? And this one, I'm going to be able to cancel out the LCD. So I'm just going to have 5 here. So I'm just going to have here 1 plus m minus 1 equals 5, right? So 1 minus 1 is 0, so m equals 5, right? And I don't have to reject the solution, so that's my answer, right? I don't always recommend doing it like this, skipping all these steps, because you can kind of mess yourself up when it's a complicated problem, so I do recommend doing it like the previous problem. All right, number 16. Number 16. For which of these values is the expression defined which it cannot be expressed as this? So what you could do, which I'm not going to do with you, but you could plug this in the calculator, right? You could plug this in the calculator. You could say, right, wherever I see an x, right? So for this one, you would plug this in the calculator, right? You'd plug in, let's say, don't ever plug in 1 or 2. So always plug in something like 3, right? So you could put in wherever you see x, 3 minus 6 times 3 plus 2. And you're going to see what that gives you, right? You're going to see what that gives you. So they're asking which one of these cannot, right? So see what this gives you. This is going to give you 3 minus 6 is, and if you could choose another number, don't choose numbers that are too large, right? So maybe 3, 5, something like that, right? And then whichever one this answer does not match, right? Because it says cannot, does not match, that one is your answer. Which expression is not equivalent, right? So if you did this, minus 3, so that's going to be 3 minus 6 is minus 3, times 5 is going to be negative 15, right? So you're going to check which one of these, when you plug in 3, is not going to be negative 15, right? So you could just do that. You can do that on the calculator. I'm not going to do that. I'm going to show you how to do it algebraically. So one thing you want to do here is which one is not equivalent to. So I'm just going to expand this. I'm going to expand x minus 6, x plus 2. All right. This is going to be x squared minus 4x minus 12. All right. So which one of these cannot be written as that, right? So this thing factored is this, all right? This thing factored is this, right? So that's what I'm getting. Okay, so let's check all our options. Which one can't be written like that, right? So let's take a look, right? First one, I have x plus 2. So, and now I'm going to factor this one, right? So I'm going to factor number 1. So I'm going to have x plus 2 times, what are the factors of negative 24 that add up to negative 2? Well, that's negative 4 and negative 6. So I'm going to have x minus 4 and x minus 6. All right, x minus 4 and x minus 6. Sorry, x plus 4 and x minus 6. And I'm going to have x plus 4. Right, so that's what the first option looked like after I factor. I can cancel this out. This is x plus 2 times x minus 6, which equals this. So this is not going to be my answer. Second one, I'm going to do the same thing, right? X times x is x squared. X times 2 is plus 2x, right? Now, negative 6 times 6, x is negative 6x. Negative 6 times 12 is negative 12. So I'm going to get x squared minus 4x minus 12. Remember, and this equals that. So these two are equivalent. This is all equivalent. So I'm also going to reject this answer. So it's asking which one it can't be. All right. And now let's check number 3. X minus 2. What are the factors of negative? Okay, so we already did that, right? So we can do x minus 6, factors of this. Remember, we already did that earlier. Okay. X minus 6, x plus 2 over x minus 6. All right. So over here, these two cancel out, but I just have x minus 2, x plus 2. I want x minus, is that going to work out? No, that is not going to work out, right? This does not look equivalent to this, right? So this one is not going to work out. Sorry, this one is not going to work out, that means it's actually going to work out because this is not equivalent, right? And I want the one that it can't be, the one that's not equivalent. So number 3 is going to be my answer here. Again, you could just choose a number, plug it in, and do it that way. And this one is the only one that's not equivalent. we don't need to keep going with option 4 because we already found our answer. All right, sequences, right? Sequences, remember some sequences, right? This asking for the 7th term of the sequence, right? So first thing you have to, this is increasing really fast, so I know it's geometric. So how do I find the ratio, right? So term after divided by term before. So this is a term after and I have a term before. By -6, so my ratio, right? So my ratio is going to be -3. All right, so remember, 7 terms, so I have 1, 2, 3, 4 terms. You could keep multiplying by -3 to get to the answer, but let's do it properly, right? So any number a to the n equals a to the 1 times r to the n minus 1, right? So I'm looking for a to the 7. That's going to be a1, which is -2, times r, which is -3, right, to the n minus 1. So 7 minus 1. 7 minus 1. 7 minus 1, that's going to be -2 times -3 to the 6th power. All right, so let's put that in the calculator. Let's see what we get. Second quit, I'm going to have -2. That's my first term times -3. That's my ratio to the 6th power. The 6th power, that's what I want. Then it says so -1458. -1458. I think that's actually the year the Ottomans took over Constantinople and renamed it Istanbul, right? So a piece of history. So my answer is going to be -1458, right? Which might be on your world history exam if you're taking it. All right. Don't quote me on it. I'm not a history teacher. That might be the wrong date. All right. So this one is asking, given a of x equals x to the 4 plus 2x cubed plus 4x minus 10, and b of x equals x plus 2, it's asking to determine what your answer is. So it's asking you to determine q of x plus r of x. So this is just long division again, right? So let's do the long division really quickly, right? So I'm going to have my divisor x plus 2. I'm going to have x plus 4 plus 2x cubed plus 4x minus 10, right? 4x minus 10. Oh, as you can see here, I'm kind of missing something, right? I'm missing and 2x squared here, right? That's fine. Let's just keep that in mind, right? Okay, what do we do here? Leading term divided by leading term. X to the 4th. X equals x cubed, right? So x plus 2 times x cubed, which is going to give me x to the 4th plus 2x cubed. Now I'm going to subtract all that. Subtract x to the 4th plus 2x to the 4th. All right, 2x to the 3rd power, sorry. Boom, right? I'm going to write my quotient, which is x cubed. All right, so these two cancel out, and what do you know, minus positive minus, and these two also cancel out, so I'm left with 0. So I'm going to bring them both down, right? 4x minus 10, right? I'm going to bring it both down, right? Wow. Okay, all right. Now I'm going to see, remember, leading term, all right, divided by leading term. So 4x divided by x equals 4. Equals 4, so I'm going to multiply that by the divisor, x plus 2 times 4, right, which is going to give me 4x plus 8. All right, so I'm going to subtract that whole thing. 4x plus 8. I'm going to subtract this whole thing. All right, okay, 4x minus 4x, this cancels out. So this is a minus, so this is minus 18, right? So write my quotient here, right, plus 4, right? So what is this? Minus 18, can x go into minus 18? No, this is, so I'm going to write it as a remainder minus 18 over x plus 2. So that's my final answer. X cubed plus 4 minus 18 over x plus 2. So is this a factor? Is b of x, x plus 2, a factor? No, it's not a factor. Why? It's not a factor because it has a remainder. It's not a factor because there is a remainder after polynomial long division. All right. Last problem, number 19. Wow, I've been recording for too long. This is my Saturday, and I'm sick. So let's go. All right. So it's asking which expression equals 0 or which expressions are equal to 0 for all real numbers. All right. So this looks like a lot, right? So if you're having trouble doing it, if you're pressed for time, right, what I recommend, you're going to set x equal to, let's say 3, and you're going to set y equal to 4, right? And whenever you see this, you're going to just put it in the calculator. You're going to put in something like, 3 squared plus 4 squared, and have the whole thing squared, and then you're going to do 3 squared plus 4 squared, and minus, and so on and so forth. And remember, it's asking for which one of these equals 0. So does this equal 0? Does this equal 0? Does this equal 0, right? Which one of these are true, right? So you can plug in two numbers, use the same numbers for all of them, and see which ones are going to equal 0, right? That's a strategy you can use. So the strategy one I'm going to deploy, it's algebra 2, so it's all about the algebra. So let's work it out, right? So x squared plus y squared plus x squared plus y squared minus 2 x squared plus y squared, right? So this is going to be, all right, this is going to be x to the 4th plus 2 x squared y squared plus y to the 4th. Same thing over here. This is going to be plus x to the 4th. Sorry, this is y to the 4th. X to the 4th plus 2x squared y squared plus y to the 4th. Right, this is just a simple binomial expansion minus minus 2. If I expand this I'm going to get x to the 4th plus 2x squared y squared plus y to the 4th, right? So if you noticed, right, if you combine all the like terms, see, these are the same thing twice, right? So it's asking, and you're minusing the same thing twice, right? So this whole thing, right, if you can combine the like terms, but if you notice that these two are the same term, so this is technically, right, I could rewrite this as 2x squared plus y squared minus 2x squared plus y squared, right? So if you notice that these two are the same, this is just going to give you 0, right? It's the same thing minus the same thing. So I know 1 is going to be in the answers, right? So I'm going to automatically reject 3 because I know 1 is going to be in the answer. Now I have to check 2. All right, so let's work out 2. X to the squared plus y squared. So this was for 1 squared minus x squared minus y squared. All right, let's do this properly, right? If you missed how I did it over there, right, I did it really fast. So x squared plus y squared minus y squared, x squared minus y squared. All right, so this is what this whole thing means. All right. Okay, so over here, you're going to have x to the 4th plus x squared y squared times x squared plus y squared x squared, y2 times y2 is plus y to the fourth. All right, and over here you're going to get x to the fourth, all right, minus, right, this whole thing is in parentheses, minus x squared, y squared, minus y squared, minus plus x squared is going to be minus y squared, x squared, minus y squared is going to be plus y to the fourth. All right, so let's work this out, right? Let's work this out. X to the fourth plus 2x squared, y squared plus y to the fourth minus x squared. So I have minus 2x squared, y squared here, right? So these are the same like terms, so I can combine. So minus is going to have positive 2x squared, y squared, minus positive is going to have minus y to the fourth. All right, okay. So what am I going to have here? All right. So this is x to the fourth. Right. This is not going to work out, right? Just because I can cancel this, but these two, they add up, so it's not going to work out. All right, so maybe you should do this in the calculator, right? This is so tedious. 1, 2, 3, right? But if they ask you to determine this algebraically, this is what you would have to do. All right, so next problem is asking, 3 is asking for the same thing, right? For the same thing, okay? For the same thing as this one. You can see that these are the same, right? X squared plus y squared minus x squared minus y squared. So same thing. So you don't have to do the algebra all over again. You don't have to do the algebra all over again. So remember, all we had remaining were these two terms. Okay? So I'm going to add these two terms together. So I'm going to have 4x squared y squared. Remember, I had these two terms. That's why I couldn't equal 0. I wanted to equal 0. And now I'm just going to subtract this term right here. Minus 2xy squared. So I'm going to have 4x squared y squared. I'm going to distribute this to 2 to the second power is 4, x to the second power is x squared, y to the second. Okay, so this equals 0. All right, so 1 works and 3 works, which is the only option. So number 4 is the only option. So please check your answers. Make sure you know how to do this, right? Please study for the exam. I want you all to do well. And best of luck.